ići tamo zbog slajdova, da. A? Pa čekat ćemo ju. Ili ćemo ju maknuti ovdje?
Recording in progress.
Ćemo ju maknuti sa ovog ili ćemo čekati? Za sad to postaviti. Da, možda tako ili možemo, ma imamo 5 minuta, možemo. Da, možemo. Ako ne, ma i registracije još malo, nek se napuni ovoga. Imamo vremena. Aha, super. Onda ćeš ju pozvati. Dobro, ja ću sam pozdraviti, dati Zvonku riječ, onda ću Zvonko ima ovu prezu, pa ću ja onda prezeti.
Dobro, može.
Mislim tražiti minutu šutnje za Klenjača, je to običajno?
Nije baš konferencija, da. To je za službeno tijelo. Ali, dear memories, ne znam, šta ti misliš, Zvonko?
A to je kod nas običajno, ne znam kako je.
Minuta šutnje, pretjerano.
A treba, ali to je naš običaj.
To je naš običaj, ali kad je član kolektiva, formalnog, a ovo nije baš formalno. Više ćemo ga se sjetiti kao velikog znanstvenika.
Da, okej. Dobro, da. To sam mislim, ne znam koliko...
Nekad nemaš ništa reći čovjeku, ali Klemešu svima puno.
Da. Ma nećemo, da. Budem ja pozvao, reći ću to Petra i tako. Ne znam mu kažem, to su naši običaji. No, ali dobro, da se ne čude ljudi šta je sad to, ne znaju se ni ponašati. čekaj, pa gdje je Grasa?
Molim?
Grasa.
Čitamo Grasu, rekao je da dolazi.
Rekao da dolazi.
Neka gospođa koja prezentira putem Zooma se još nije spojila.
Šta ti prezentira?
Ne znam. Ti imaš nekoga preko Zooma?
Jedino za Words.
Za?
Za Words.
A za Word? Pita kako se zove.
Good morning, dear ladies and gentlemen. We welcome you all in the lovely city of Dubrovnik, the city of freedom and free citizens, which maybe you are wondering why I'm telling this. If you read the poem at, at our webpage and your invitation letter, you will see that this poem is glorify the freedom as the highest pressure of our society. That's why we are here to speak freely about sustainability, about sustainable development, and this is our ultimate goal for this conference. We are also running in a hybrid mode, so I'm welcoming all of you following us on the internet, and I'm glad, really glad to see you all here in this large number, which means that we survived one crisis, and let's hope that we will go through all the others that are in front of us. We are running this conference since 2002, and it was a project of Professor Carvalho, Professor Afgan, Professor Dujic, Professor Bogdan, Professor Ružinski, and Professor Ivo Šlaus from Croatian Academy of Science, and we owe them a lot because of this great conference, and we also owe a lot to the person sitting next to me, Professor Zvonimir Guzovic, who is a conference secretary since 2003, and he also is helping us with organizing all of this conference, so I would like to give him an applause, and I would like to give him a word to.
Okay, thank you. Dear colleagues, friends, ladies and gentlemen, it is my great pleasure and honor to welcome all of you to the 18th SDEWES conference, Dubrovnik 2023. For this conference, 636 participants from 58 countries are registered. We will have 577 oral and 84 poster presentations. This is excellent and points to the importance of SDEWES conference, especially when we remember the recent catastrophic phenomena that are direct consequence of global warming. The summer of 2023 was Earth's hottest since global recording began in 1808. The months of June, July, and August combined were 0.23 degrees Celsius warmer than any other summer, and 1.2 degrees Celsius warmer than the average summer between 1951 and 1980. August alone was 1.2 degrees Celsius warmer than the average. This new record comes as exceptional heat swept across much of the world exacerbating deadly wildfires is Canada and Hawaii, and heat waves in South America, Japan, Europe, and USA, while likely contributing to severe rainfall in Italy, Greece, Central Europe, and Libya. Global average sea surface temperatures remain at record high levels for the time of this year from April to August. The high sea surface temperatures have coincided with the initial development of El Nino conditions that lead to warm temperatures across many parts of the planet. UN General Secretary Antonio Guterres warned on last Wednesday that humanity's dependence on fossil fuels has opened the gates of hell, opening a summit on climate ambitions in New York, unfortunately without USA and China. Speaking of terrible heat and historic fires this year, fueled by greenhouse gas emission, he stressed that it was not too late to limit the increase in global temperature to 1.5 degrees Celsius. The future is not written. It is up to you, the leaders, to write it, he said. I would add also scientists. The SDEWES family is constantly growing from 140 participants at the first conference held in 2002 to 636 participants at this conference. Moreover, in addition to the traditional Dubrovnik SDEWES conferences, we also have a series of Southeast Europe conferences, Latin American conference, Asia Pacific conferences, and from next year, a North American conference. Finally, I am sure that you will enjoy again not only the technical presentations and valuable scientific discussion, but also the local hospitality, food, culture, and sightseeing of beautiful Dubrovnik. I wish all of us a successful conference. We hope that COVID is behind us, but be safe and stay healthy. Thank you very much for your coming and for your attention.
Thank you, Professor Guzovic. Now I will just repeat some of the numbers during my introductory presentation, just to see how we are going, and then we will continue with the program. As I already mentioned, this conference started actually as a small European project in the framework 5, which was organized by University of Zagreb and the Instituto Superior Técnico from Lisbon, and now University of Lisbon. We are running this conference almost for more than 20 years, and now we are also have our International Center of Sustainable Development of Energy, Water, and Environment Systems, which is one of the executive organizers together with the other organizations involved in this. Also, we have a partnership and a patronage of Ministry of Science and Education and UNESCO, and also we have just a small number of the basic sponsors, but they are important, and we are looking forward to get more sponsors in future, because it's easier to organize conference when you have support. If we're going to see a little bit of numbers, so we have more than 600 participants from 58 countries, 270 cities, and almost 300 universities. But from this picture, we can see that most of participants come from Europe, and this means that maybe the travel is not as easy as it was before, but we are also looking forward to see you on our future conferences, which thankfully to Professor Dujic, will be organized in North America, in Latin America, in Australia, which means that we will give opportunity to all these regions in the world to participate in the, I would like to say, the best conference on the sustainable development of energy, water, environment system. And we have many of conferences organized until now, so you can see that from first conference here in Dubrovnik in 2002 to conferences all around Europe, but also one in Latin America. Hopefully next year it will be successfully organized for the third time. We had the Asia Pacific conference that was also organized, but unfortunately it went on a hybrid, but next year you will have a chance to visit it in person. As I already mentioned, this conference and now the series of these conferences is the result of European project with a small amount of funding, but then having the snowball effect. You can see that from really small incentives and visions, you can have really huge results. And by huge results, we are very proud to host all these people, and now here we are again growing, and this is the biggest conference in history of SDEWES conferences. So we have almost 636 participants that are registered. We know that there were some issues with the flights and the storm going here 2 days ago, but let's hope that many of you will be able to attend in person. And also we are running in a hybrid mode, which means that we have all presentations online, and this gives us a little freedom that you will be able to check if someone is missing. At least we have a recorded presentation. Why this conference is so successful? Because we are publishing many of special issues. And we are quite proud because the conference now published around 3,000 papers in really good journals, in distinguished journals. And people will like to say that maybe it's easier to publish journal in special issues, but with SDEWES it's not the case. In SDEWES we are publishing the best papers in the special issues, and that's why the journal editors like the SDEWES conference, because all of our special issues are actually increasing their impact factor of their journals. So this is why important to have all of your papers published, and we hope that we will continue to have good cooperation with these journals, and actually there are metrics in which we can show that how conference papers are contributing to importance of the journal, but also of sustainable development. Then, when you are receiving so many good papers, of course it's hard to fit them to even into all the special issues. We started our own journal of the SDEWES of Sustainable Development of Water, Energy, Environment Systems, which is now run by Professor Neven Dujic, who is editor-in-chief. It's open source journal. It's indexed in many of databases. And what is the most important, since last year, we have the impact factor, which is 2.1. I hope this is a big achievement of this conference, but also of the International Center of Sustainable Development of Water, Energy, Environment Systems. I hope this journal will grow together with the other special issues, and we hope that you will manage to publish in it, but it's now even becoming also harder and harder. As I already mentioned, we are running this conference in a hybrid mode, and that's why it's important to have your presentations online, but also it is important that you check your presentations, and which gives you opportunity to answer all the questions that you will not be able to answer during the short presentations. Or we are running 10 parallel sessions here. We have people online, also in hybrid mode, and that's why it is important that you check from time to time, and also to discuss and making this conference more successful. Of course, that we will have some time, to discuss the papers, but let's hope that you will also get some certificates for your achievement, your activities, and you can also follow us in real time, and there will be also the quite good invited speakers here, and you will be able to watch these speeches again in our SDEWES online platform, which we call the SDEWES Talks. So you can find many of SDEWES lectures there. You will also be introduced to rules of conference by my colleague Tomislav later, and there will be a group photo at the end of this opening session. So we would like you to invite you later for this photo, so don't go away. Now, as I told you, this conference is really successful because we have an excellent international scientific committee made from the greatest scientists in sustainability topics. We are a multidisciplinary conference, and we owe a lot to the members of International Scientific Committee who are dedicated to the work for the conference. They make editorial work, they make review of the papers, they select the best papers, and that's why this conference is very successful. So now I'm really sad to have to say that one of these members is not more with us, one of the greatest scientists that I have met, and it is Professor Jerzy Klemeš, who we own a lot. And really, he put a lot in this conference. He was a member of supervisory board of the International Center of Sustainable Development of Energy, Water, Environment System, and he was a member of many of the boards of the conference. I must say that I'm missing him a lot, especially because this is one of the first conferences that he's not here, and we were enjoying in all discussions, all questions that he posed, and he was really one of the greatest scientists that I've met in our field. So I would like to invite Professor Petar Varbanov just to remind us of some good memories and how big person was Professor Klemeš. Thank you.
Good morning, everyone. I would like to thank Professor Kajacic for introducing me and for opening the discussions. Coming back to Professor Jerzy Klemeš, he was a truly remarkable scientist as a personality. I must say, we are going to see the influence of his legacy. It's still yet to come to realize it. So, to focus on specifically this SDEWES conference, we started our involvement with the conference. I think it was 2009, the first one. At least this is the oldest one which I could dig in my memory. This is how far we go. he was a part of the International Scientific Committee, and then he became one of the leading persons taking part in forming the programs, award committee, a lot of discussions. We have had a lot of new members of the SDEWES family brought through our session, and it was almost exclusively because of his drive and his networking skills. So what we have here is just a couple of pictures from the few last conferences, networking and talking at the conference. Here is what we had last year in Vlora. So this was the last conference where we had him with us fully and interacting. So his achievements are very serious. He managed to put Brno University of Technology on the map of science a little bit higher. So in addition to him, it's also me, Professor Stechlik, Dr. Fan. Dr. Fan should be around here somewhere. So he was recognized by the European Federation of Chemical Engineering, and there is what to be recognized for. Many projects, many conferences, a lot of editorial work. So this was the last project he initiated. We are still completing it. It's about combined cooling, heating, and power in buildings. The coordinator here is Krakow University of Technology. And it's not to discover new things. This is a demonstration stage project. Where it all started, it's a very nice picture that I would like to show. I'm not sure how many of you would recognize people on this photograph. We have Professor Klemisch here on the left-hand side. As a very young scientist, I think it was taken in 1994 or 93, something like that. This is the Department of Process Integration at UMIST in Manchester. So many of the people in that picture who you see sitting on the floor actually are now leading professors around the world. So as a result of so much work, Jerzy achieved very good impact, and the numbers which I put on the slide are just an illustration. I think the impact is much well beyond the numbers. So Web of Science or Scopus, whatever you open. This is one of his first works on heat exchanger networks in 85. Last century. This is a variation of the grid diagram with vertical arrangements. And this is, I'm just picking some points because it's impossible to cover everything, but this is my first involvement with him. We were working on heat exchanger network retrofit. Another important thing is he wasn't the initiator of the total site concept, but he was the person who put it on the map of science. It took a lot of persuasion to persuade the co-authors in this paper to actually publish it and start developing the concept. So something like, what is it, 90? So 10 years after that, they expanded the concept to not just have industry involved, but also residential and other urban actors which also can share and benefit from the sharing of energy. And the concept went along. So after this establishment, firm establishment in the roots of energy efficiency, Professor Klemesh also expanded the frontiers. This is the first project which I know about where he considered environmental impact alongside energy. It was a project for harvesting solar energy and storing it as a chemical energy in a chemical reactor for hydration, dehydration of certain salts. And they made the life cycle analysis. Then moving further was the realization that it's not just one environmental impact we have to track, there are many. On the other hand, the engineers and policymakers, to make a decision, they need something which summarizes. So this is how they came up with the environmental performance strategy map, which puts many environmental impacts and costs in one picture. Then, of course, came the development of supply chains for energy, the energy planning or power planning on industrial sites in time, and the most recent developments. This is the last development of total site integration for water with our latest PhD student who now works back in Malaysia. So all this research, we can go on for a few hours, but I think the point is clear. So all this research materialized in a lot of books. And I'm not sure if there are not more. These are the books I know about, because I took part personally. So we have the food industry, the first book on energy integration and sustainability, the handbook of process integration, 2 editions, the encyclopedia, the three editions of process integration and intensification with integrator, and our book on utility systems. So Professor Klemesh, besides being involved heavily with SDEWES and research, he was also the Cape Working Party chair for 8 years. This is our last Cape meeting at Escape in Graz in 2018, where he handed over to the current Cape Working Party chair. So this is the history of Conference Press. Many of you have been participants there. We've been partnering with University of Zagreb on it as well. And it's still going on. It's going to be held soon in a couple of weeks in Thessaloniki. So journals, maybe many of you have received a decision from Professor Klemesh on a paper submitted to any of these journals. So it's many journals we collaborated with. They're overlapping to a large extent with SDEWES, which is not a surprise. We've been tightly collaborating. And of course, the basis for this were lots of projects, patents, software. So just to come to the close to this short reminder of Professor Klemesh. In a couple of weeks, on the 9th of October, we will hold a special forum at the beginning of the Conference Press. It will be in the morning. We are working to organize a Zoom session, so we will circulate it to everybody who wants to take part in the forum itself. So, thank you very much.
Professor Klemesh will always stay in our memories and our hearts, and let him have eternal glory, as we can say here. Thank you, Peter. And now we know that we are electing politicians to make decisions for us. So it's quite important to then put some advices to them, etc. But politicians need to make decisions. We are scientists, we just provide them numbers and calculations. Of course, it's very important then to have a scientist as politician. So it's my great pleasure to now announce Professor Maria de Graça Carvalho, who is a member of our International Scientific Committee and actually it's chairing it, but it's also a member of European Parliament, our highest body, which make decisions for all of us, which is selected by us and doing it for us. Professor Carvalho had quite a nice vision of future energy systems 15 years ago. But at that time, European industry didn't listen so much to Professor Carvalho. She said that future energy systems will may hold on 4 pillars, which are, of course, renewable energy, buildings as a positive power plants, energy storage, which means when you store energy, and then smart grids and electric vehicles. So it was 15 years ago. Industry didn't listen that time. I hope they will listen now, but now they are asking to protect the electric car industry from electric vehicles coming outside. So hopefully there are people who are listening to the scientists and they are making innovations and they are making competitions. So it's my great pleasure to announce Professor Maria de Graça Carvalho, who will now say something about the future of European electricity market design, which means that we need to change some things to become more efficient and to allow us all to produce, consume energy and to have, as we like to say in Europe, affordable, clean and secure energy. So, Professor Carvalho, please tell us what we need to do for the future. Yeah.
Thank you very much. Thank you very much for your kind words. Actually, 15 years ago, I had the pleasure to collaborate with Neven and also with Goran at demonstration projects, and we managed to build a power plant in an island, Port Sant, from renewable hydrogen that was quite innovative for the time, and there is a lot of technology that could be scaled up and already in use for many years, and still it's not. So the researchers and the scientists have done their work. It's a lot of work that the rest of the society could have done, and it didn't. So let's hope that this time we get it right. And but with this, I would like to start to thank the organizers and mainly Neven Dwich, and to congratulate him and the team for keeping this and growing this series of conference, the SDEWES. We usually say that SDEWES is like a family. Once you join, you don't go away, so you keep coming back. I'm coming back most of the SDEWES since 2002. So I hope that is the same with all of you. It's a very interesting conference, networking, also the possibility for young researchers to publish and to make a network and to find partners for projects. And so I think it's a very useful conference for all stages of the researchers. As a member of the European Parliament, but my profession is to be a professor and researcher in the area of energy. I'm quite pleased to give you an overview what is happening at legislative terms at European level. And there's a lot happening, as we are doing what I consider to be the biggest public policy change in public policy that happened in the modern times. when we look at the amount of regulations, directives and regulations in the last 40 years that the European Union has put forward, is really impressed and a game changer in the field of energy and the combat to climate change. Each of us as citizens has still not felt it because part of that need to be transposed to the member states, and will arrive to the member states 1 year later or 2 years later. So it's important that you are informed, that you are part of the discussion, not to be surprised with the results when it arrives to the real implementation in your day-to-day life. We are organized in 5 years periods. We are in the 4th year of this 5-year period, and in this term, the main priority was what is called the Green Deal, so the transformation with fight of climate change, but a transformation that takes in consideration the economy, the growth, and the jobs. And this is a strategy, so not a law, but just after 1 year after, we had the first climate law. It was the first part of the world that had a law for climate that makes the targets binding. So member states have to follow these targets, and the target is reducing emissions 55% in 2030 and becoming climate neutral in 2050. But to achieve this, we need to do sectorial regulations, directives, and we had 1 year after, in 2021, what we call Fit for 55, that present us to the European Parliament, because the initiative is the European Commission, a set of 17 directives that change most of the sectors, economic sectors, and present regulations or directives for these sectors. In the area of electricity production, in the area of energy production in general, in the transport sector, in the building sector, in the agriculture, in forestry, so in the transports, in all modes of transport, from aviation, shipping, road transport, all of that have directives with important transformations in our day-to-day life. I'm just going to refer probably the most, what I consider the most important one, the directive of the renewables, that it's for 2030, 45% of renewable energy, 42.5 completely binding, and 2.5 more optional, depending on the circumstances of the country. But a very interesting one is that 5% of this percentage needs to be what is called innovative technologies, so the ones that are not near the market today. And this pushes the development of innovative technologies in the area of renewables. I'm very proud because this was an amendment of mine that I had to fight until the end. This directive is completely ready, already accepted by member states, so it will be transposed to the member states and it will start to be applied. There is other parts that are important. Biomass is in and is considerable, was a big discussion also with academics, is considered renewable. And there is a sustainability criteria for biomass like it was before. We had already one for biofuels. And we have biofuels that target 5.5% of biofuels of second generation for the transport. And we have a very important target, difficult to achieve, that is 42% of the hydrogen industry needs to be of renewable origin. It's quite an ambitious target because it's 2030, and 2030 is It's quite close. One of the most polemic ones is the energy efficiency in buildings. We will have an invited lecture, the first invited lecture today in the conference. We are still negotiating with the member states, and this is quite ambitious. We have very ambitious targets for 2030 and some for 2033 to do the renovation of buildings in terms of energy efficiency. Is ambitious because the economic power of some of the European countries and the regions is not compatible with the requests of this directive. There are some exceptions. Some of these amendments were from mine. The historic buildings, the religious building, isolated buildings, buildings that are not inhabit for 4 months, so the summer buildings. There is also the requirement that all the new buildings will be zero emissions in 2030, and the public in 27. So this is also quite ambitious. And to sell and to rent, you need to have the certificate. So it means all the buildings need to have certificate. This is going to be a very challenge part of our 20 directives. The road transport, as you know, this was a big discussion. Until 2035, Europe will not sell more internal combustion engines. For the aviation, there are targets for the use of sustainable aviation fuels, 20% in 2035, 70% in 2050. Here there is a room for a lot of new research still, and also targets for the shipping, 6% of sustainable fuels in 2030 and 80% in 2050. So you see a lot of challenge. I just told you some, but I think we will manage. Just to give you the strength and the power of the European Union in this field. Before the war, we import from Russia 45% of the gas, 25% of oil, and 45% of coal. In the end of last year, we had less than 10% of importation from Russia. And we still are decreasing that very much. So what is missing on the list 27 is the electricity market design that is in certain way putting all this together. So the European Commission in March decided to put forward a reform of the electricity market design with 2 parts. One, the design of the market itself, and another regulation for avoiding manipulation of the energy price of the electricity that is called REMIT. I'm rapporteur of these files, and we have already the vote in plenary, so our position is finalized. We are negotiating now with the Council. Just very shortly, the electricity market design, I have set 3 very important objectives that I managed to include and to be approved by my colleagues. One is to put the consumers at the center, so protecting consumers and empowering consumers, protecting the consumers so they have more flexibility in fixed contracts or dynamic contracts. So a lot of options on the contracts. There is a crisis mechanism, an automatic crisis mechanism. You don't need a special regulation. If there is a crisis with certain conditions, member states can be declared crisis and they can help the consumers. But the part that I like and I think that is the future is the empowerment of the consumer. So we have enhanced the possibilities and make it easy, the auto production, the share of energy, the energy community. So it's a big part of this electricity market that is what I call future oriented, because I'm convinced this is the future, together with the digitalization of the market and the more decentralized market. So that is one of the important components. The second important component is to give incentives for investments. To do all this transition, we did a lot of investments. So there are many mechanisms to attract investments, like contracts for differences, so is the public contracts, the PPAs, power purchase agreements, and I have not accept any amendment that would damage the attraction of investments. There were amendments that were putting caps on the revenues of the inframarginal technologies. I consider that could have an effect of putting away investments to other parts of the world. So we didn't accept that. So there are no capped on revenues. And if there is a crisis, it's a different story, and there member states can act and protect the consumers. But in normal times, we should allow the market to function, and the revenues is a good thing to happen. However, for example, the contract for difference will make the revenues benefit the consumers, and that was also a point that I want, that every consumer will feel the lowering of the price of the renewables, because what happens with the present market is even when the renewables price goes down, the consumers do not feel that. So this new design is made that consumers will feel that when there is a lowering of price of the electricity production, this is reflecting the consumers and in all the consumers, not only the vulnerables. Special attention has to be paid by the vulnerables, but all the consumers, middle class, industry, SMEs, so everyone will feel that the price is coming down. The third and last point that I want to stress is the internal market, the European internal market. So we have in this new design a complete European perspective. So we have not done special provisions for certain countries, and that was the most difficult problem, one of the most difficult parts, because everyone is very specific on energy, everyone wants to protect something, and we have very strong countries that I don't need to mention, or that they want to protect the nuclear, or they want to protect the coal. So this is technological neutral, is European, and defends the European energy internal market. But for that, we also need to build more interconnections, to have a strong grid covering all Europe, not only interconnections, transmission and distribution. And there has been not a lot of investment in grids. So there are also incentives for the investments in grids, all kinds of electrical grids. So these are the three main components of the electricity market design. And on the manipulation, the second part, the remit on the manipulation, the fight against manipulation of prices, we have given more powers to the European regulators, that is called ACER, and we have increased the transparency, and we have include not only electricity, but also gas and LNG. We were negatively surprised by some recent news where some countries have increased the import of LNG from Russia, because LNG in certain way escape to the monitoring and the transparency of the energy monitoring that the European Commission was done. So now is complete. We are putting all the forms of energy. We are increasing the role at the European level and the transparency to try to avoid manipulation of the prices and to have a transparent view what is going on at the European level in terms of energy market. We have, as I told you, approved all this in the European Parliament with very good results. We are negotiating with the Council in the second part on the transparency and the fight against manipulation. Is going very well. We will finish very soon. In the electricity market, we are still having problems with some of the countries that want to have their own rules for the market. So we will see how we will finalize. I hope that it finalized before the elections. It's not a lot of time, but it will be important that we have this reform of the electricity market in place very soon. And that's mainly my message. As you can see, there is a lot of role for research and innovation in many of these areas. I would stress the integration of the systems, the energy efficiency in buildings, in spite of we knowing a lot of the technologies, all the integration is going to be a very important topic. Hydrogen, the biofuels for aviation, for shipping, all that requires a lot, still a lot of research. So plenty of opportunities for researchers, and I will suppose that will be a lot of investment in these areas because we really is for the first time all this is binding, so industry is reacting and needs the help of research centers and universities. So I hope this is useful for you. There's also a lot of opportunities in funding in Horizon Europe and other European programs and the regional funds that are Europeans but managed in the regions and in the countries. And we need your work to make sure that we have all that with clean technologies that are also affordable and accessible, because some of them are not in the market, like electrolyzers. We need the hydrogen, but there are not enough electrolyzers, so still they need to be built faster in an easy way, and also that depends on the researchers to help the industry on that. So thank you very much and good work.
Now we know what we will do for the next 10 years, and hopefully we will manage to get this more energy communities at the end. So I'm also inviting Professor Carvalho to join the panel tonight at 6. We will have a panel discussion on energy communities and democratization of energy systems. So you are all invited to come here and make questions, discussion, etc. So thank you very much. Now I would like to introduce the Professor Neven Dujic, who has also good analytic capability, and also he's good in making of visions, because 20 years ago he made vision that we will publish 3,000 papers in this journal, so we can see that it is feasible. Now he will talk a little bit about the future of gas. I hope it's not in pipelines, but I hope it's not fossil gas. So let's see what the future of gas will be. Thank you, Neven, for your speak.
Thank you, Goran. Yesterday at Welcome, I mentioned how a resilient energy system in Europe played the loss of the main supplier of energy. And today I would like to talk what is the future of gas, because that was a very important source coming from that one supplier. ESAC is an organization which is Alliance of European Academies of Science, And at ESAC, we provide with technical expert, science-based advice to the governments. We have done a report on future of gas. You can download it. It's free. If you just take a QR code, it will lead you there. So, coming back to the context, Europe managed to survive incredible change in supply of energy. In 21, we were importing 40% of gas consumption from Russia, 27% of oil imports were coming from Russia, and 46% of coal was coming from Russia. And now it has plunged for 90% for oil, 100% for coal, no more Russian coal is coming, and 86% for piped Russian gas. We can see these graphs down there. It was precipitous, and we survived. There is a big danger about nuclear fuel. Not only that Russia controls around 20% of production of uranium, it controls now with the Niger added to the allies, probably around 60 to 70% of the fuel supply. So we should be very careful about going nuclear. What happened with this gas? There was a huge reduction in the Russian piped gas. There was a slight increase on the right side of LNG from Russia, but it's so small compared to the loss of piped gas that it's negligible. We had significant new LNG being supplied to Europe from various sources, but the main reason that we managed to survive was demand reduction. And this proves that the markets worked perfectly. The point of markets is that if you have smaller supply, demand has to go down. And if markets work perfectly, that means that those that needed the gas the least will give off gas, switch to some alternative fuels, or move production somewhere else. Alternative would be to have cuts, administrative cuts. We had that in Eastern Europe, and it was really bad for the economy and for the population. So markets worked perfectly. They don't need tampering. They don't need changing. Marginal markets work. All this demand reduction was not a loss of production. Half of that demand reduction was because we switched to other fuels, to renewables. There was quite a lot of new renewables, to more efficient technologies, a little bit to coal, but that was a relatively small amount of energy. So we are doing excellent job in very fast transition, and in a way we can thank this unfortunate international crisis as a push to do much faster transition. When we look at where the gas is used in Europe, it's mostly in the buildings. And this is a problem because buildings are difficult to change. We need to invest in new infrastructure. This is why the buildings are actually the most important sector where we should concentrate our effort to remove gas from the equation. And Professor Carvalho has shown that we are working on that, and Professor Norton will show later how. But there are some issues we should take into account. Because of this switch to LNG, I think the time has come to look into carbon footprint of LNG and piped gas. because some are better, some are worse. We have to account for this methane because this leaked methane makes natural gas worse than coal in heating if we have only 3% of leakage. So we should be accounting for methane. Because methane is a very powerful greenhouse gas. When we look at 2100 a year, then it's okay to look at global warming potential of a 100-year period, which is already very high. But we are also thinking about what happens in the next 10 years. We are seeing that climate change is already having a significant impact. So we should look at also at the global warming potential of methane leakages in 20 years, and that one is 86 times higher than CO2. So removing the leakages or reducing the leakages of natural gas should be one of the priorities of any policy. So what about the buildings? We have excellent heating and cooling strategy in Europe since 2016. This was based on Stratego project, and nothing happened. We continue to put gas boilers in new buildings. And in this strategy, there are no gas boilers. We go district heating or we go heat pumps. So there is a problem. There is a whole series of buildings directives. Why do we need a new buildings directive every few years? Because the whole point of buildings directive is to remove fossil fuels from heating, but there is always a lobbyist way how to keep it there. So, in my opinion, as long as we are going to use primary energy as a criteria for the quality of energy used in buildings, we are under spell of gas lobby. So, one way how to move against fossil fuel heating is to include heating in ETS. That would be a very good measure because we would put the price on carbon. We will see how it works. We are moving into that direction. Some countries have already banned gas boilers or are moving into banning gas boilers, although there is a big fight in those countries against that. We will see how it works. But the European Union should basically ban gas boilers in any new and retrofitted buildings since at least 10 years ago. There was no point in continuing with putting fossil fuels into buildings, which are very difficult to remove, because once you have them, it's economic to keep them for at least 20 years. So it's a very long lock-in effect. We don't have such a lock-in effect in industry or in district heating or in power production, because it's very fast to move. When gas gets more expensive, we just use some other fuels or we move faster to renewables. Gas boilers in buildings is the most difficult issue, in my opinion, of decarbonization. So there is a fancy idea to put hydrogen in gas pipelines. Well, let's look what does it mean if we heat our houses with green hydrogen. For green hydrogen, we need to have renewables. If we use these renewables for heating, using heat pumps with COP3, then we are going to have 3 times more heating energy used for heating. But if we produce hydrogen, green hydrogen, then we have to pump it, we have to compress it, and then we burn it. We actually get 6 times less low temperature heat used for heating, 6 times. That means we need 6 times more wind turbines and solar panels. Do we really want that? If we go to electric methane, it's even worse because we lose on methanization of hydrogen, and we get around 10 times, we need around 10 times more energy than if we do it directly with electric energy. So why would anyone want to do that? When we think about recommendations of the report, we should go energy efficiency first, always. We should ban installation of new gas boilers in buildings, since they consume around 40% of natural gas in EU. We should push the switch towards heat pumps or district heating, depending on the density of heat demand. We should publish local heat maps because they're very useful for local policymakers to decide which way to go. And we should update heating cooling strategy for Repower Europe and better address local heating planning challenges and phasing out gas boilers whilst phasing in heat pumps and district heating. And we should also accelerate ETS2 for heating needs. On the other side, in power generation, around 30% of natural gas in EU was used for electricity generation. The taxonomy is recognizing natural gas as a transitional fuel when it replaces coal. It might make sense, but it's losing sense. I think in February 22, it has completely lost sense to do that. We need to go fast into renewables. Renewable electricity generation and grid infrastructure is critical for the acceleration of deployment of clean energy sources. We need probably some electricity market design, but I think it works well. We just need some better design of measures to push more renewables. And the renewable electricity supplied to hydrogen electrolysis, we need that, but we should be careful not to cannibalize the use of electricity for decarbonization of the power sector. If we look at curves, they are very optimistic. Wind and solar has been bigger than fossil fuels for first time in May this year, ever. And if we look at wind and solar together, it has become the biggest source of electricity in 22 already, bigger than nuclear. That is a bit thanks to the fact that French nuclear power plants were mostly shut down last year. So they will probably come back a little bit, but it's a clear direction where we go. So we think, and the ESAC report shows clearly, that natural gas is no longer a transitional option for replacing coal. So we think taxonomy update is needed, and we need to increase urgently renewable supply in order to limit global warming to 1.5 degrees. And we need a higher renewable target in policy. We have ended decreasing it to 42.5%, but 45 is a minimum that we should have. So, what about hydrogen? I don't know if you ever heard that hydrogen is around 2% of final energy use in Europe. Hydrogen is big. 2/3 of that is used for producing of fertilizers, and 1/3 of that is mostly in refineries for hydrocracking. So this is obviously the first hydrogen that we should aim our green hydrogen to. We should not spend hydrogen where it will not stay, like for heating. We should use it where we already use it, and then after we do that, we should go into industries that cannot be electrified easily, and then push it there, like steel industry, for example. Europe has very optimistic goals for this hydrogen, and it plans to import significant part of hydrogen, which will be interesting for some countries. That's why we are organizing SDEWES next year in Chile, because Chile has enough of renewable resources to supply all this hydrogen. Australia also. So there are plenty of places with huge possibilities. But we are not going to bring hydrogen by boats. This doesn't work. Thermodynamics doesn't work. We lose 30% of energy by liquefying hydrogen, and then 1% is leaking every day. And hydrogen has a quite high global warming impact. It's around 5. So we don't want to leak hydrogen. So we will probably be bringing ammonia or methanol by ships instead of pure hydrogen. Piping hydrogen from North Africa maybe makes sense. That can be done technically, but shipping, not really. And then another important thing is the idea of blending hydrogen into natural gas. This is the most crazy idea I ever heard in my life. You know, it doesn't make any sense. If we put 10% hydrogen in, mix it with natural gas, we only reduce CO2 emissions for 1% if it's green hydrogen. So let's not waste green hydrogen on something that will not work. Because you cannot do more than 20%. If you do more than 20%, you have to reduce the pressures. So basically, you have to go to 100%. If we are going to pipe hydrogen, we need to do it 100% hydrogen pipelines. Blending is just a greenwash. So this is important message that we scientists who understand this message should be sending to policymakers. To end, we should use energy system integration to reduce greenhouse gas emissions. We should prioritize renewables that deliver low operating and low embodied greenhouse gas emissions. Wind and solar generators have low operating and embodied emissions, so we should use them with demand response, heat storage, sustainable backup generation. Hydropower can be dispatchable, so we should optimize it, its annual contribution at EU level, and we should monitor impacts of climate change on water flows, because this is a coming problem in the next decades. Regarding biogas and biomethane, we should produce them only from the wastes, and we should use them for high value and hard to electrify applications, so again, not for heating, because they're a limited resource. And we should minimize leakage of the high global warming potential of methane. Thank you.
Thank you, Professor Dujic, for your providing us vision of the future of fossil gas, but also other gases. Are there any burning questions, maybe for our introductory lectures? It was not common to ask the questions, but we have time to, if there... Online, okay, so we have people from hybrid, okay.
Yes, we have one question, online question. The question is, what is the role of nuclear energy in the EU strategy? It wasn't even mentioned.
Maybe that's the reason why it was not mentioned, but please answer. Yeah.
The nuclear is there. All the strategy in certain ways tries to be technological neutral, so taking in consideration that it should be low emissions technology, Recently, as probably you know, there was a lot of discussion. Nuclear was considered a low emission sustainable technology in the taxonomy debate, in the taxonomy regulation in the EU. So nuclear is part, like renewables. But the choice of technologies or the choice of energy mixing is a responsibility of the member states. So each member state is free to choose the mix of technologies, taking in consideration the targets that they have to achieve of very strict targets of reduction of emissions. So the member states that decide to choose nuclear, they will choose nuclear. On the electricity market design, nuclear is there, and as the renewables is treated exactly in the same way. But there has been a big debate because there are benefits for the new investments, but not for retroactivity. It means not for installations that already exist and that do not do any improvements. And the countries that have a lot of nuclear are claiming that they want retroactivity of benefits for the existing power stations. And that will give a lot of advantage for the countries that have a lot of nuclear power stations. I'm thinking about mainly one. That will be a way that they can regulate with very low price the energy and to do unfair competition in the industrial sector with all the other member states. So in the European Parliament, we didn't accept that. So there is no retroactivity, only the ones that want to improve the power station. So if nuclear wants to improve, if it wants to extend the time with the improvement, retrofitting, it's entitled to these benefits. If not, it's not entitled to the benefits. This question is still under discussion in the Council, and is the only point that is preventing the Council to close the file. Is this special, the fight between France and Germany, because the German has a certain way afraid that the industry will suffer from this retroactivity, but will not be only German, Italy, everyone, but especially the ones closer and more industrialized would be damaged by this retroactivity of the investments of power stations that didn't improve in their investments. So this is a big, big debate and fight between France and the rest of the European countries at this point. But in the European Parliament, we solve it, and I think that it's the correct way, taking consideration if we want to have electricity market that is fair and improves the competition and a fair competition between the member states and a truly energy internal market in Europe.
Thank you. Just to repeat that we met here to discuss sustainable development, which means that we need to satisfy our own needs. We are a little bit greedy, but we must not to compromise the ability of the future generations to satisfy their own needs. And then we need to think about future generations. And for me, it's difficult to think about people that will live here 10,000 years to 1 million years in this planet. And this is how long we need to protect waste from nuclear power plants. Of course, we know how to make it safe, but as a researcher, I'm not sure how I need to discount the operational and maintenance cost of these facilities for 10,000 to 1 million years. So this is something that we will need to discuss, and that's why we are here. Sustainability of nuclear power is really important issue, and we are here to discuss it. Hopefully, we have a time for one short question, if it is really short. No, there was one before, so Professor Kirkish, will... Yeah, please. Huh? You can ask one question.
Yeah, my question will be short. I'm Ivo Potov from TU Delft. And first I would like to, thank all the speakers for the really inspiring presentations. I have a question on the market, electricity market design. There are increasing issues with congestion on the distribution and transmission grids. And to what extent are these issues going to be mitigated with the new market design?
Yes, is one of the points that we try to provide a solution in the new market design, special also with the offshore electricity generation, and all the solutions are to be agreed with the regions and to the member states. So there is an important part of the new regulation that takes in consideration and solutions for this problem, but it puts also the regions and the member states involved in that solution. It's addressed.
Okay. Thank you for the answer. And now we need to move on with the program because the rain is coming and we don't want to Photoshop the sky. So, Tomislav, can you please, Professor Pukšić will try to explain a little bit of the rules of this conference and how we need to behave to have a successful conference. Of course, that we understand the crisis problems, so if there are any of issue with your flights or the health, we can make some exceptions, but in general, we like to follow the rules. Okay.
Yeah, we need to follow the rules. Okay, thank you, Goran. Ladies and gentlemen, I'm very happy to be able to welcome you on our 18th SDEWES conference. I'll be very short, give you a few information and a few pointers regarding the conference implementation, let's say. First of all, as you probably saw already, this is a hybrid conference, which means we have an online participants and we have on-site participants. The reason why on-site participants had to pre-record their presentations and their research is because the online participants can also have access all of your papers and all of your research. But whether you're online or whether you're on-site, the key issue is that you actually present your paper. That's the most important thing. Otherwise, unfortunately, the papers would be cancelled. Of course, since we had different kind of delays regarding flights, etc., so if there's some kind of emergency case, there's always a possibility to switch to online sessions. When it comes to presenting your paper, especially for people that are here for the first time, if you're doing it in a session or in a poster session, or I mean oral session or a poster session, it's quite nice for you to be in your rooms around 15 minutes before the session starts, so you can copy your presentation, so you can test if everything is okay. Someone from the local organizing committee will be in the rooms 15 minutes before. They will assist you in any way. More or less the same advice applies to chairs and co-chairs, so it's also nice to be there a little bit earlier because it's nice to meet the people that will be a part of your session, the session you are chairing. Okay, some other pointers. So when it comes to lunch, we will have lunch in a restaurant which is right in front of this main corridor with the rooms A, B, C, and D. You all got your lunch coupons. So for each day you will have like a lunch coupon and you will just give it to the person in front of the restaurant. Another point, we will have a social visit on Wednesday. And you also got your social visit coupon, depending on which trip you have chosen. So you had like three options, but you also had an option just for the dinner, or if you didn't want to go to the social visit, your coupon would be just lunches. There will be additional information regarding the social visit on Wednesday morning with all the data. We will post it all around the conference venue, but you also have all the data on the conference website. So I would suggest for all the information that you might have, you can always check the web page. Of course, if you have any questions, issues, problems, you can always come to the registration desk. Someone from the local organizing committee will be there, and we would be very happy to assist in any way. Finally, also maybe a short info. This year we have quite a lot of side events, which are quite nice and diverse. So we have energy planning and tool development in interenergy. We have integrated assessment models in locomotion. We have smart islands in Insula. We have SDEWES project exchange on Friday, which will be very interesting for people that want to connect and try to find potential partners in different kind of EU project consortiums. We also have a workshop on energy supply and resilience of energy systems. So quite a lot of side events, and I hope you will find some of them interesting and join us on these side events. Final note, after the award session, we will have a group photo. Hopefully, if there's no rain outside, then the group photo will be just when you exit this main hall, go out to the terrace and right. We will have like there's like a terrace there, and we will have our group photo there. In case the rain starts in like 5 minutes or 10 minutes, then the group photo will be in the main hotel lobby. Okay, that's it. I was very short. Of course, as I said, if you have any questions, any issues, you can always come to the registration desk. We will be very happy to assist in any way. So, thank you.
Thank you, Tomislav, for the nice introduction of the rules and the opportunities. And now maybe we need to say this is the part of the opening sessions that we are waiting the most, because we will announce the winners of awards for this SDEWES conference. And I'm inviting Professor Natasha Markovska, SDEWES Center Vice President, to also say who are winners of the awards. So I hope we will also manage to have them. Some are online, but some are here in person. So Natasha, the floor is yours. Thank you.
Thank you, Goran. Esteemed guests and participants, it is a privilege and honor to extend a warm welcome to all of you to the awards session of the 19th SDEWES conference. In this session, we come together to celebrate the remarkable achievements of various individuals of our community. So today, we will recognize and honor the authors of most cited papers, the authors of best papers, the most loyal SDEWES conference participants, and in addition, we will also present an honorary award to a distinguished colleague who has made significant contributions to the success and growth of the conference over the years. So this session promises to be a momentous occasion where we will acknowledge the outstanding work and dedication of our community members. Thank you for joining us, and let us proceed with celebrations. Most cited papers. We start with most cited SDEWES paper, which is award presented to the authors of the most cited paper, which was published in the SDEWES special issues of the Associated Journals. The selection process for this award involves counting the citations received by each SDEWES paper over a span of 2 calendar years after the publication. Then this number is divided by the journal's impact factor in the year of publication. So it means we measure the contribution of that paper to the impact factor of the specific journal, and the paper with the highest score in this calculation is recognized as the most cited paper. The recipients of this award will be presented with certificates from SDEWES, along with a book authored by a member of the SDEWES International Scientific Committee. And this time, we acknowledge the winners of the most cited paper from the SDEWES 2018 conferences, specifically first Latin American SDEWES conference Rio, third SDEWES Southeastern European SDEWES conference Novi Sad, and the 13th SDEWES conference Palermo. So, the most cited paper from SDEWES 2018 conferences investigates how solar combined cooling, heating, and power systems based on hybrid PVT, PV, or solar thermal collectors can be applied in buildings. It is authored by Maria Herando, Antonio Pantilio, Kai Wang, Christos Markides, and was published 2019 in the Journal of Renewable Energy. The award is a book written by Professor Henrik Lund entitled Renewable Energy Systems, a Smart Energy Systems Approach to the Choice and Modeling of 100% Renewable Solutions. I hope the first author, Maria Herando, is following this session virtually. So I would like to invite Maria to address the audience.
Good morning, everyone. First of all, I would like to thank the SDEWES Center for this award. I really was not expecting it. And then I would also like to thank Professor Palombo, which I believe is there, that will be getting the award on my behalf. Thanks. I hope to see you meet soon. I'm very sorry I couldn't attend this year's conference for personal reasons, but yeah, I enjoy a lot and I love Dubrovnik. So thanks a lot. I really hope to see you all next year in the next SDEWES conference in Rome. Enjoy your time there. Thank you.
Thank you, Maria. In fact, Professor Professor Adolfo is with us, and I would like to invite him to receive the award on behalf of authors.
Thank you. On behalf of Maria. Thank you so much. Thank you.
Then we go on with most cited SDEWES paper. This award recognizes the authors of the most cited paper published in the Journal of Sustainable Development of Energy, Water, and Environment Systems. The selection process for this award involves also counting the number of citations received by each SDEWES paper over a span of 2 calendar years. The paper with the highest citation count is acknowledged as the most cited SDEWES paper, and the recipients of this award, besides certificates and a book authored by a member of SDEWES International Scientific Committee, would receive an extra token of appreciation in a form of 2 SDEWES coins. The monetary value of 1 SDEWES coin is equivalent to the SDEWES publishing fee. So the awarded authors will receive 2 waivers for publishing their work in SDEWES. This time, we will be honoring the winning papers from the volume 8 of SDEWES. So the most cited SDEWES paper from the volume 8 is titled Preliminary Energy Assessment to Improve the Energy Sustainability in the Small Islands of Mediterranean Sea, authored by Domenico Curto, Vincenzo Franzita, Marco Trapenese, and Maurizio Ciricchione. The distinguished authors of this paper will be honored with a copy of the book titled Assessing and Measuring Environmental Impact and Sustainability, authored by Professor Jiří Klemeš, and 2 SDEWES coins as a token of appreciation. I don't know whether we have a present author here. If not, let us check. Do we have authors online? No, so we will deliver the award later on, but let us jointly congratulate to the authors on this outstanding achievement. Best Paper Awards. It is a prestigious recognition presented to the authors of the top 3 papers, and the selection process involves 2 phases. The first phase is a nomination phase, and during this phase, all reviewers and editors nominate candidate papers for the Best Paper Award from the papers they are reviewing or editing. Then selection phase comes into stage, and in this second phase, each member of the award committee selects 2 favorite papers from the pool of candidates. So we got a short list of papers to move in the second phase of individual evaluation. In the current evaluation for this conference, there were over 40 nominated papers, out of which 8 papers advanced to the second phase. These 8 papers were individually assessed by the members of the award committee, and the final ranking is determined based on the average scores assigned by the committee members. The winners will receive certificates from SDEWES and a book authored by a member of SDEWES International Scientific Committee. And allow me to introduce the esteemed members of the award committee, all of whom are distinguished members of the SDEWES International Scientific Committee. Professor Antonio Piacentino, Professor Ingo Stadler, Professor Kioa Wang, and Professor Alexander Zidanšek. These dedicated professionals have played a crucial role in this rigorous evaluation process to identify the exceptional papers for the Best Paper Award. Now, without further delay, let's proceed to unveil and celebrate the outstanding authors of the 3 winning papers. The 3rd Best Paper Award goes to the following outstanding paper: Theoretical analysis of using multiple borehole heat exchangers for production of heating and cooling energy in shallow geothermal reservoirs with underground water flow. Authors are Amalia Lekic-Bretschneider, Luka Perkovic, Tomislav Kurevia, and Maria Matenic. Notably, the first author of this remarkable paper is a female researcher from Croatia. Congratulations to the authors for their outstanding achievement. The book Process Integration and Intensification, Saving Energy, Water and Resources will go to the author team as a well-deserved recognition. Regrettably, the first author was unable to attend in person or virtually, and the presentation of the award will be arranged later on. Congratulations once again to the authors. The author team of the 2nd best paper comes from China. The paper considers rational synthesis and thermochemical properties regulation of nanostructured materials for efficient CO2 conversion. The esteemed authors of this remarkable paper will be awarded with a valuable book co-authored by Professor Jiří Klemeš, Sustainability in the Process Industry, Integration and Optimization. I would like to invite Boxi Cheng, the first author, to the stage to share some words with you and accept this well-deserved award.
Good morning, everyone. I'm Bo Xigeng from Harbin Institute of Technology, China. It is my honor to win this prize. And firstly, I want to thank to the SDEWES conference and the committee. They have helped me a lot about some visas and publication issues. And I have bothered them a lot through the email. So, and the second, I want to thank to also the conference, because they gave me a chance to get in to show my latest project and to give the latest results and give us a chance to communicate about the renewable energy use and the environment. And finally, I want to thank to my research group. They helped me a lot. Thank you, that's all.
So, the prestigious Best Paper Award, considered the top honor among the papers, goes to the paper entitled Analysis of Power P2G to X Systems with Metal Hybrid Storage Based on coupled electrochemical and thermodynamic simulation. Authors are Michael Barif-Rudy, Simon Mayswinkel, Malte Fenning, Stefan Schedler, Barbara Schiffer, Gert Steinbach, and Tanya Klies. Congratulations to the authors of this exceptional paper for achieving this distinguished recognition as the best of the best. The award, Professor Henrik's Lund book, goes to the first author, Michael Barif-Rudy from Germany.
Thank you very much. It is a pleasant surprise and an honor to receive this award. I want to extend my thanks to the SDEWES committee and to my colleagues for helping with this paper and collaborating. Thank you very much.
Yeah, before we move on the next award category, I would like to highlight that we have achieved a commendable geographical representation among our awarded recipients. The first authors of the winning papers hail from 3 different countries, showcasing the diversity and international reach of our community. We have 2 European countries represented, Germany and Croatia, and 1 Asian country, China. And furthermore, we have maintained gender balance, with the first author of the 3rd best paper being a female researcher. Now, let us transition to the next award category, the Loyalty Award. And this award is dedicated to recognize the most loyal participants in SDEWES conferences. Based on the participation statistics, we are proud to announce that the recipient of the Loyalty Award is Professor Laura Vanoli from Italy. Professor Laura Vanoli has exhibited remarkable dedication and loyalty by actively participating in all of the main SDEWES conferences since 2015. In total, 9 conferences. In recognition of her remarkable loyalty to the SDEWES conferences, Professor Laura Vanoli will also be honored with Professor Henrik Lund's book. Laura will be arriving later today, so she is unable to join us during this session. But I would also like to extend the invitation to Professor Adolfo Palombo to represent Laura and receive this prestigious award on her behalf.
I didn't do anything, just on behalf. Thank you so much.
The final and most prestigious category of awards is the honorary award. This award is presented to an individual who has made distinguished and exceptional contributions to SDEWES conferences. As we reflect on the legacy of this award, it is worth noting that the distinguished past awardees who have enriched our community with their outstanding work. Professor Naim Afgan, Professor Jordan Popjordanov, Professor Simeon Oka, Professor Ivo Schlaus, Professor Kemal Hanjalic, Professor Maria da Graça Carvalho, Professor Vyacheslav Kafarov, Professor Henrik Lund, Professor Jiří Klemeš, and Professor Tarik Kupusovic. Each of these awardees has left a remarkable mark on our community through their dedication and contributions. Today, we eagerly anticipate the announcement of this year's honorary award recipient. And it is with great pleasure that I announce the recipient of this year's honorary award. This prestigious recognition is bestowed upon Professor Nikola Różyński. Professor Nikola Różyński has been an integral part of the SDEWES community since its inception. He played a significant role as a member of the local organizing committee for the first 3 conferences and has been a dedicated member of the International Scientific Committee since 2007. His enduring commitment and substantial contributions to the success and growth of SDEWES conference make him a truly deserving recipient of the honorary award. Congratulations to Professor Nikola Różyński for this well-deserved honor.
Thank you. I'm not sure that I deserve so much for my work. I have been a member of the group when I was at the University of Zagreb. In the first years, I was active. Then, when I moved to another job, to the Ministry of Science, and later to Ministry of Energy and Environment, I did do something what have helped to better understand in the public that the work of the energy saving and the work of the saving the environment on the way that our scientists can contribute and find and work to find solution. It was not, the job is not finished yet. And I'm very grateful or honored to receive this award.
As we come to the end of this award session, I would like, on behalf of the award committee, all SDEWES members, and personally, to extend our heartfelt congratulations to all awardees. Your remarkable achievements and contributions are truly commendable. Let us all join in a round of applause to celebrate the success of our awardees. And I would like to invite all the awardees and members of the award committee to come forward for a joint photo here on the stage. Furthermore, I would like to remind about a family photo, inviting all participants to join us for a family photo. And with this, I officially close the award session and declare the Sustainable Development of Energy, Water and Environment System Conference officially open. Thank you all for your participation.
Okay, please go to the terrace and then right to the stairs, so we will have the big photo there. On the terrace and the right.
On the stage, please. If not, maybe, yeah, maybe we will, yes. We go for
So just outside to the terrace and to the right.
Very practical concerns.
Let's do it quickly.
So someone puts the slides up, yep.
I
They
can,
will be up, the slides will be up.
Slides and check. Do you have the slides?
No, they were sent. They were sent.
Okay. To whom? I don't know.
I could go get them for the room, but they were sent. They were, you know?
To Marco,
But I do have another copy. These are the reasons I check.
I see they're not here. Ah, sorry, found it.
There you go.
Found it.
That's it.
It wasn't off just.
That's okay. That's
I,
no problem.
I
That's
thought
no problem.
maybe it's
This is why I check.
maybe it's in the folder. Okay, we can.
Okay, so when I start, it's up on the screen, and just click forward. Yeah, yeah.
Do it
So just click. Okay, lovely. Thank you very much. That's brilliant.
Thank you very much.
Okay,
I'm looking forward to this.
Okay, good.
Lecture.
Okay,
But
excellent.
now-
And practical things, and I sit.
But let's go for
Do I
the.
sit down there or here with?
You can sit here.
Okay. Yeah. Just.
bell, ring the bell. To je super, ok. Gotovo, da. Spori su jako u hotelu sa pravljenjem kava. Da. Mislim, čekao sam pola sata na kavu i onda sam odustao i filterušao si natočio. Da, da. Da. Džezvi. Da. Je, super je bilo. Savršeno. Da, ja sam malo produžio zato što sam vidio da ima previše vremena, a onda sam ti još dao pitanja pa je malo bilo na knapić, ali super je ispalo. Da.
Sad moramo računati barem 3 do 5 minuta.
Ja. Molim? Da, kuš, ja te sad tu čeram, onda je ručak i onda popodne imam sesije u kojima moramo sudjelovati, tako da ručak je tu odmah u restoranu, s ovom karticom uđeš unutra, ali ručak mislim kreće za sat vremena. 12:30 se šetati. Pa odimo, da. Dobro, može.
A navečer ti voziš
Ne, bit će transfer, znači trebaš, ako te ne uhvate, pitat na recepciji od konferencije. Kad ide transfer, da. Ne, auto ćemo ti dati, napisat ću ti. Napisat ću ti na WhatsApp poruku kad dolazi, ali budete našli, samo trebaš biti negdje u hotelu, jel?
Ne, bit ću u hotelu, da. Ovdje ću baš se malo, idem i novine neke naći, tako da nisam tako.
Dobro, okej.
Telefoniraš.
Okay, let us start. We are continuing our program with invited plenary speech of a very distinguished researcher with whom I had the honor to work with as a part of ESAC on the Decarbonization of Buildings report. Brian Norton's research has made significant contributions to the development of solar energy technologies and wider aspects of building energy efficiency and sustainability. Sole author of 2 books and co-author of another 9 books, over 500 research papers, including 200 in major international learned journals with over 14,000 citations, H-index of 60, supervised over 55 PhD students. He serves as Associate Editor of Solar Energy, the premier international journal in the field, and serves on 8 other editorial boards and been awarded over 15 million euros in research grants. He's a member of Royal Irish Academy and a fellow of Irish Academy of Engineering. He has honorary doctorate in University of Technology, Troyes, France. He has received Napier Shaw Medal. He is a member of Chartered Institute of Building Service Engineers. He has received the Roscoe Award from Energy Institute. He's a honorary fellow of Chartered Institute of Building Services Engineers with their highest honor. He is a co-author of 2012 American Association of Publishers Prose Award-winning book, Comprehensive Renewable Energy. He is honorary professor at University of Ulster, Harbin Institute of Technology, and Beijing Wuxi University, both in China. Adjunct professor in University of Houston. I think his CV is really impressive. And he's going to give us today a lecture on strategy of decarbonization of buildings. Brian, the floor is yours, 45 minutes.
Good morning, ladies and gentlemen, and thank you, Nevin, for that introduction, after which anything I can say will only be disappointing. What I'm going to talk about is decarbonisation of buildings, and let me do the health warnings at the beginning. There is no single strategy for the decarbonisation of buildings. It depends on the climatic context, the function of building, occupancy, and many, many other economic, social, and cultural factors. And I would advise any of you working in this field, when you look at any advice in this area, whether it's in a textbook, online, or wherever, to look where the persons are located, what tacit, what unwritten assumptions have been making about the built environment as they devise their strategies. The other thing I would say, by way of sort of a health warning at the beginning, is that buildings are not primarily energy systems. They serve another primary function. So, for example, this room is a lecture theatre. Its primary function is to serve that role, and it needs to do it energy efficiently with the lowest carbon emissions. But if you do that and it doesn't serve its primary function, it's failed at its point. And I'll be making that point a few times within this talk. So you can't just look at buildings as energy systems. You need to always be cognizant of the primary function. And just before I start, just like the work presented here comes out of work that I had the honour of co-chairing in the European Academy's Science Advisory Committee, and also work that's funded by research funders in Ireland, where I'm based, and by funders of Velux, notably in Switzerland, NSF in the US, and the EPSRC in the UK. So get my thanks to the funders in early. Okay, some of what I'm going to discuss, certainly the early part of this talk, has already been touched on by others and would be well known to people in this room. So in the later part of the talk, I'll talk about some of the more quirky aspects of decarbonisation of buildings that may be less well known. Okay, well, the first thing is, why are buildings important? If you're trying to look at the EU perspective, looking at emissions and climate goals, buildings consume about 40% of energy use, large amounts of gas overall. That varies with context. So where countries have, for example, high renewable energy contributions anyway, perhaps from hydropower, as you might see in some countries. Obviously, renewables contribute more. In other countries, coal, notably. Where I'm from in Ireland, there'll be a very strong penetration of oil into the housing sector. But broadly speaking, there's a huge opportunity for reduction. That reduction can be readily met by electrification and by particularly the adoption of heat pumps and district heating. So there's wide opportunities to seriously address the emissions from buildings. Essentially, what it's trying to do is reduce the emissions from the building itself, decarbonise the building. That is by introducing measures that are going to reduce the heat loss, perhaps increase the solar gain, store some of the heat and electricity that's generated perhaps by solar panels, solar thermal, photovoltaic systems on the building, so that the building is able to reduce the amount of energy it consumes and export energy into district heating networks or to the grid. So you're decarbonising at the demand side in the building itself. That also, by the way, requires a market that enables that demand side energy sales to be enacted. So your building occupants move from being consumers of energy to also producers of energy, so-called prosumers. And that's another sort of side of it in terms of whether that market actually exists so that those transactions can take place. The other thing that needs to happen is that the residual electricity to meet those heat pumps, for example, that comes to the building, is met from decarbonised sources, is met from renewable energy primarily, although if you regard nuclear as a decarbonised sustainable source, it could be met from nuclear. And that needs to increase substantially, and actually needs to increase substantially over the amount of electricity in total that's currently generated. Because you're also seeking to decarbonise industry, you're seeking to decarbonise transport, so electric vehicles. So there's a lot of other demands on decarbonised electricity. One thing, and I'll come to it a number of times in this talk, is that balance between to what extent you decarbonise the supply and to what extent you reduce the energy requirement of the building itself. And if you did it at a technical level, that would be a kind of marginal abatement cost curve. You'd look at the optimum between whether the investment at the demand side was appropriate or investment at the supply side. The challenge with that is that the boundary conditions for those calculations are continually changing, and new technologies are emerging, for example, and there are various externalities, hidden assumptions in there, for example, that people are rational economic actors, that make those kind of things problematic. Also, there are instances where, as we'll see later, where people do not have the ability to pay for the measures that they rationally should take, so-called fuel poverty, and that comes into equations as well. So there's intersections between energy policy, social policy, as well as, if you like, the division between supply and demand side. Also, there tend to be, in many systems, entrenched actors who want to maintain their market positions, so that you discussed earlier on, for example, the people who maybe want to bring hydrogen into a domestic building situation. In my view, a completely mad idea. But the idea is because the gas industry saw the electricity industry became vectors for renewables and saw an opportunity for themselves to occupy a similar market position. So incumbent actors also influence the reality of how these things get played out. So essentially, you'll reduce the energy demand, and you can see a little graph on my insert there of how actually building regulations for new buildings have gone down over the years and have tighter and tighter requirements. And supply decarbonised electricity, decarbonised heat from district heating to those buildings as the combined strategy that needs to be adopted. And this is part of a long journey, and I'm grateful for this particular paper this year, a paper by Torelli and Bassano, which kind of summarised, if you like, the trajectory of how things are going to change in buildings, and also some of the nomenclature, from business as usual to near energy buildings, near zero energy buildings, net zero carbon buildings, carbon negative buildings, and absolute zero energy buildings. And I don't want to get tied up in all that kind of terminologies, but they're basically stages on a journey to which buildings move from being just supplied with energy to meet loads that aren't particularly controlled, to being net carbon sinks. And that is possible in certain climatic conditions, in certain types of buildings. Not, I should stress, for individual buildings in all climates. So there's a kind of journey. So we look maybe at just a little more detail at maybe the first stage of that journey, and the net zero energy building. And this simply is a building which has reduced its energy load, but has solar thermal, PV, it may have a heat pump, for example, that can be part of a district heat network. So when it is producing energy with the heat pump, but it's not being used in the building, it can go into that network. Or indeed, if it's a historic building, it may be actually drawing heat from a district heating network, which might have solar thermal, geothermal, heat pumps, etc., all linked to a network. So at certain times, it requires energy. At other times, it will be send out energy to the grid. The illustrations on this slide are to illustrate for me, these are new net zero energy buildings, is that achieving a low energy building is aesthetically, is architecturally neutral. It doesn't imply any kind of architectural style or any architectural conceit that needs to be adopted. And all these buildings, quite different, are all net zero energy buildings, from very large scale domestic buildings using atria as glazed spaces to preheat ventilation air, to buildings that are doing a large amount of thing around direct gain, storing solar heat from day to night, assuming primarily even occupancy in a domestic setting, through to very, very traditional forms. So a whole range of different architectural forms emerge. However, this kind of conceptualization for a consumer is not very helpful. A net or near zero energy building is actually meaningless to a homeowner because, as Nevin said earlier on, primary energy for electricity is time and location dependent due to the mix of generators and can rapidly change depending on how much gas is on that is used to generate electricity, how much renewables, etc. So your primary energy density is actually changing, at a 5-minute interval almost, depending on the kind of market structure, and is a primary driver of whether a building is net zero energy. So, and also it allows things like installation of PV and the counter of the export PV to offset imported fossil fuels as somehow a decarbonisation strategy, and not actually deal with the intrinsic loads within the building itself. So one needs care in terms of applying these kind of metrics. And my view is that it is the actual energy cost in the building itself, it is the building fabric, it is the efficient use of the energy within the building that needs to be measured and need to be the objective of energy saving measures. Otherwise, you can have perverse incentives to simply have PV on the roof, for example, which does nothing for the actual energy use in the building, or indeed simply encourage decarbonisation of the grid and have a lot of stranded assets which are producing electricity for winter heat peak loads, which are not necessarily the rest of the year, which have a net effect of increasing the overall cost of electricity to all consumers as a penalty for the few that don't decarbonise their buildings. So there's a complex set of interactions there. This also, by the way, applies to new buildings primarily, and new buildings are relatively easy to decarbonise. You set a regulatory framework that requires a certain, below a certain energy use per square metre. You set regulatory frameworks that require a certain amount of renewable energy to be installed, may even require heat pumps, would certainly require that you don't install a gas boiler, etc. And that all achieves a lot within new buildings. However, the rate of new buildings is always small. Buildings within the past 2 or 3 years are rarely more than 2 or 3% of our building stock, and in a recession could be even less. So new houses are a minority. And that leads you to this. And essentially, this is a snapshot of Europe based on energy ratings. I'm going to talk about why this is not necessarily as good as it looks or as informative as it looks a little later on. But essentially, the red here are the buildings that need refurbishment. And the little bit of the green at the bottom is essentially representative of the new building stock in these particular countries. So the real challenge with decarbonisation is not new buildings. That is met by regulation, is met by building standards, is met by a whole lot of measures. The real challenge is in the renovation of buildings and seeking to reduce the energy use in existing buildings. And there are multiple challenges in that respect. So what that involves is, and this particular example is of a social housing block, actually in Estonia, before and after energy refurbishment. And what it involves is improved insulation. How much depends on the particular country and the climatic context. Usually what's called a volumetric addition, which is that if you've got, as in this case, for example, balconies, they're enclosed and made part of the building, so that there are other gains as part of the process to the occupants. Draft proofing, reducing ventilation rates, very low heat loss windows, triple glazing, etc., vacuum glazing, things like that come into the play there. Renewable energy generation, so there'll be PV on the roof, etc. There might even be, as I say, excess energy produced from a heat pump, which is essentially stored for energy from summer to winter. That would be going to other occupants within the building. So a whole range of measures. Okay, but it isn't not as simple as it might appear. So, for example, if you look at the other picture I've got, which is a thermograph of a row of buildings, you might have several buildings that are refurbished, but one that is not. And this is because occupancy, ownership standards, tenancy, etc., comes into play here. So, for example, if you have a landlord, the benefit of energy refurbishment accrues to the tenant, not to the landlord. So a social landlord that has many properties and has a social mission might refurbish all their properties. A private landlord may not, because it would not necessarily make economic sense to them unless there are the granted incentives to do so. Also, if you're an individual homeowner owning identical homes, you could be in a different situation in terms of the mortgage that might be on that property and thus the cost of housing, so that if you still have a mortgage on that property, additional costs on the building may not be achievable, affordable. If you don't, they are. And also other issues to do with the economic position of the occupants come into play. So it's not simply a matter of a causal, we have low energy use, therefore we refurbish. There are a whole range of ownership, economic, social factors that also come into play. And because of all those factors, it needs quite complex and subtle interventions to alter perceptions and alter how those particular individuals are going to be able to refurbish the buildings based on their particular circumstance. And it's very difficult to devise regulations that either aren't too generous to people who don't need incentives, or can be gamed by people, or misdirected importantly. But it's important that actually it is done. This, and I should explain, this is a calculation we did for the European Cannabis Science Advisory Council report, and huge range of very hairy assumptions behind this. So, but the broad message, I think, is clear. What this is if you looked at the effect when you work it through to global temperature rises of refurbishing buildings in Europe, and it assumes everything else remains constant, which of course it won't. But nevertheless, just as an illustrative exercise, it's quite interesting. And if you had just business as usual, if you did not refurbish buildings, you did the decarbonisation of the supply system that's planned, etc., you'll completely overshoot any kind of target in terms of reducing global temperature rises. Even with the current EU renovation wave, which is lagging behind in progress of where it actually should be, and still remain a whole range of challenges, as I mentioned earlier on, by the economic capacity of various countries to support the kind of interventions needed to enable homeowners to refurbish their houses, even that is barely going to be able to achieve a 2 degrees Celsius temperature rise. And certainly the idea of a 1.5 degrees global temperature rise has gone out the window. So if you relate these things to end targets in terms of global warming, and you've got a whole lot of intermediate stages of the actual emissions, how they're affected climate, etc. Certainly the renovation, where the renovation of existing buildings is critically important. Okay, but I mentioned that I discussed some of the key challenges that there are in buildings. And one starts off with actually what do we know about energy use in buildings? And what might to some of you be surprising is that no country anywhere actually measures how much energy is used in buildings. Sounds surprising. So there's a whole lot of policy interventions to be made, and there's actually no evidence base whatsoever as to what the energy use in buildings actually is. What they actually do is they use the energy ratings of buildings. And what an energy rating is a calculation based on a standard set of assumptions to do with climate, occupancy, etc., that are then essentially modified to the particular physical characteristics of the building at a particular point in time. What is its heating system, how well insulated it is, what's its glazing system, etc., floor area, those sort of things, to produce a rating. And the original intention of ratings was as a means of offering government grants for refurbishment of buildings. Okay? So you're comparing, if you like with like, that this building by this method gets a better rating than this other building. Okay? And that's okay. As a comparative rating, it's fine. But then what's happened is the numbers associated with those ratings, and bear in mind the building's only rated when it's applying for a grant or when it's sold or rented, and when it's constructed. So not all buildings are rated, okay? And not all buildings are equally rated by type. So you find that there be rather more social housing that's rated than, for example, large detached houses. You'll find different rates of rating depend over time, depending on what grants were available, okay? So you might have 5% of the buildings in a particular category rated, and then that's extrapolated for the number of buildings in that category. So 5% of the semi-detached houses in the country, say, will be rated. That rating will be extrapolated to all the semi-detached houses in the country, and that is what the government will use to say that's the energy consumed by those buildings. That is all flawed, because the theory behind that is that whilst the individual rating may not apply to the particular building, because it's all comparative, all right, summed up, some will be higher, some will be lower, etc., and it'll all iron out. That has proved to be a false assumption. So as you see from this graph here, these are graphs of actual energy consumption against theoretical energy consumption for buildings where actually measurements have taken place. And essentially what happens is that the energy ratings of new buildings are too generous, and that's because the occupants of the buildings take some of those gains in terms of improved insulation, etc., in terms of higher comfort temperatures. They sit in their T-shirts and shorts more into the winter, okay, and consume more energy. So you get what's called a rebound effect. So new buildings are seen more efficient by a rating system than they actually are. Older buildings, even more interesting, are not as energy inefficient as you'd think they would be. And the reason for that is an assumption in these calculation methods that buildings remain, in terms of the building fabric, at the state they're in at the time where they're constructed, according to the building regulations at that time. The flaws in that argument are twofold. One is that the building regulations at that time represent a lower standard, and many builders will build above that standard, inadvertently or intentionally. So even at the point of construction, most buildings are not meeting the minimum standard. But also through their lives, householders improve insulation, they add parts of the building, garages, conservatories, additions, which provide a thermal buffer to the building and are also better insulated. They might draft-proof the buildings, etc. So actual energy consumption in older buildings is not as high as people imagine. That has important implications in terms of how you calculate what is the appropriate refurbishment intervention. If you don't know your starting position, how do you get to your end position? So lots of issues to do with the rating of building. Now, there's also, I should say, an awful lot of work on trying to improve rating systems so that they don't have this conflict between what this idea of being a rating system and actually being used then for national policy in terms of buildings. Another issue, and again, it's been touched on already, is that buildings are part of a system. And looking at buildings in isolation can achieve a suboptimal system. So you've got buildings that might have, for example, a PV prosumer, battery. There might in the future also be fuel cells in buildings, there'll be heat storage, etc. But there's a whole lot of other parts of the building, parts of the system, where there'll also be storage with varying timelines and varying technologies. For example, a PV operator might actually have batteries at the PV field, at the PV generation point, so that they can achieve a better capacity factor to the grid by supplying stored electricity from their own batteries, for example. A grid may choose to have hydrogen. One of the potential applications of green hydrogen is, for example, in generation in the depths of winter and effectively storage for that. The other one, by the way, is decarbonisation of industry. But they may have hydrogen storage at the grid level as well. You might also have pumped storage. We do in Ireland, do in Wales, for example. So you've got pumped hydro. So there's a whole range of storage options within the grid. And it leads to very critical questions about where you store Is it at the demand side? Is it somewhere along that supply chain? What you store, is it electricity? Is it heat? Is it potential energy in hydropower? And why you're storing it, for what purpose? In other words, is it to discharge at the end of the day? Is it summer to winter? Is it to regulate the grid, etc.? And all those choices of storage are become very important in terms of the interventions that are made at the building's end as opposed to different parts of the system. In other words, look at the whole thing as a system becomes important. So, for example, I was just mentioning before I came up that the intervention of district heating in Ireland, which would not traditionally have district heating systems, is currently has two sources. One, which is the heat generated by data centers, of which we host a large number, and they use a lot of heat, okay, and they can be used in those localities. But in other localities, it's geothermal, and geothermal going into district heating because we have lots of long extinct volcanoes which have left a residual heat signature in the ground. So looking at systems aspects, and those systems aspects then saying, well, the dwellings are also linked perhaps with educational facilities, linked with hospital facilities, etc. in those networks, then gives the kind of loads and balanced loads over time that makes those kind of systems viable. So looking at things from a system perspective is particularly important. Let's say a bit of a random walk here, but one other issue, and this actually came up very much in the COVID-19 pandemic, is indoor air quality. And this goes back to a point I made right at the beginning, in that the primary function of a building is not to save energy. The primary function of a building is to be in habitation, is to be a lecture theatre, is to be an operating theatre, is to be whatever it is, and needs to achieve that role perfectly. And one of the critical roles, particularly if you look at domestic buildings, is to provide a healthy, comfortable internal environment with the amenities that people wish. Healthy and comfortable. And part of a drive toward low energy buildings was to reduce air change rates, reduce the ventilation rate in buildings, because you've essentially got a fabric heat loss and you've got a heat loss of that warm air being expelled from the building. That is not a good strategy, because what it means is that you've then got a persistence of the air, the quality of the air in terms of the pollutants in the environment, again, depending on the cooking culture, etc. But as particularly came true in the pandemic, also the ability to flush the air, flush airborne pathogens out of the building is reduced if you've got very low air change rates. So strategies in the future are going to be some combinations of the preheating of ventilation air, either in non-domestic buildings through, for example, atria as a source of a preheated ventilation air, or through double skin windows, etc., combined or separately having mechanical ventilation heat recovery from the building and having that controlled in such a way that it's controlled by the air quality within the building. So air quality accepting a higher air change rate, but then having an intrinsic energy conservation strategy around that, rather than simply reducing the air change rate itself, becomes important. So some of the sort of measures that we're taking in the past in terms of very low air change rates are very unwise in terms of various aspects of human health. Most of them discussed on that figure. A similar thing happened in terms of how buildings had windows. You see these trends where people are saying heavily insulated buildings, very, very small windows with lots of low energy lights, and that's a strategy. It's flawed for a whole range of reasons. Over the last 15, 20 years, there have been a lot of discoveries about how the human eye interacts with the human circadian system, our body clock. And there was a discovery of a new type of cell within the eye, intrinsically photoreceptive ganglion cells, which control the human body clock. And it responds to green, blue wavelengths that are particularly prevalent in the solar spectrum, and it's why we like to be in environments where there's lots of green around us, for example. And artificial lighting, traditional artificial lighting, does not have those wavelengths in the spectrum. So from a point of view of providing circadian health, etc., artificial lighting, you might have as well have been in a dark room. So having too much artificial lighting is bad for your health in terms of that process with the building. Also, for the eye development in children, unless they get regular exposure to sunlight, you get short sightedness, myopia. And so there are now so-called pandemics of myopia in places like Singapore, Taiwan, etc., where children move from indoor environments through underground passageways to indoor environments that are in shopping centres, etc., because of the climate, because of the hot weather, essentially, and never actually see the sun. They see a lot of artificial lighting. So a whole range of sort of adverse consequences of no daylight. So much more of an interest in terms of much more daylight coming into buildings, better for human health, better for human development, etc., has an influence on the form of buildings, which is going to be important in the future, but also has an impact on energy. And that is that if you look at a low energy light bulb, it consumes a fifth of the energy of an incandescent light bulb. Okay, about a fifth. Okay, if you saw a typical domestic situation maybe 20 years ago, you would have seen a room would have been lit with one incandescent light bulb. Okay, the same room today will typically have 10 recessed LED light bulbs. So your LED light bulb uses less energy, about a fifth, but you've got 10 of them, so your energy is actually doubled. So lighting energy use is actually going up. So increasing the use of daylight in the building to displace electric lighting is becoming proportionally important, and it's becoming proportionally important because all the other energy uses are going down. So designing for daylight, as you see in the diagram here, is also becoming important. So trends around reduced air exchange rate, very small windows have kind of bottomed out, and you're seeing trends going the other way, which imply highly insulated windows, triple glazing, vacuum glazing, etc., shallow plan buildings, but also, because again, avoiding inadvertent consequences, overheating, avoiding glare, working out glare much more carefully, and discomfort glare, etc. So a whole range of trends within buildings. The other very big and very well-established trends is that if you looked at the regulatory environment around building regulations, it has been primarily concerned with operational energy use. In other words, what energy is actually consumed in the operation of the building. But as you reduce the operational energy use, the actual energy in the construction, maintenance, etc. of the building becomes more and more significant, the so-called embodied energy. And it's embodied in materials, but also embodied in the transport of those materials to the building, etc. And you see these kind of things of looking at energy over the life cycle, and you see various things where you see these kind of ideas of a pyramid of materials depending on how sustainable they are, with steel and concrete at the bottom, essentially, and wood at the top. Now, that's very simplistic because you can recycle steel, and you can increasingly see various versions of concrete that have low energy content. But nevertheless, hierarchy there. But there is always an embodied energy associated with materials you put in buildings. This also applies to building refurbishment. So when you're refurbishing buildings, you'll see you can reduce the energy use, but in the very act of doing it, you're increasing the immediate energy embodied in that building. So there is a payback period over which your operational emissions need to be recovered. So this graph here, you see this line, that period of increase, you've actually got increased global warming, increased emissions because of the renovation. Okay, but the operational use is going down, eventually pays that back, and then you start saving energy overall. But if your goal is to reduce CO2 emissions in the short term, okay, you can't have that energy payback period for the embodied energy against the renewable the operational energy too long. It needs to be as short as possible. So again, look at the embodied energy material becomes very, very important. It also has an implication because the targets that government set for energy refurbishment have a cost optimum. So they're ending up moving from a rating E maybe to a rating B of some kind. But if you brought embodied energy into those calculations, and you also brought into those things calculations around what the actual energy use of an older building was, which I say is not often as much as you might think, the optimum calculations also change. And in fact, the net effect of all that lot is that the targets for refurbishing buildings should actually be very substantially increased. So, some big issues that come out of that. I mentioned earlier on, one of the big issues are the economic, social factors in this. And it's not my particular area of expertise, but I think it's important that it's included in the discussion, because a lot of the barriers to energy efficient in building are not technical. They are market structure issues, they're social issues, they're financial issues of various kinds. So you see a whole range of new measures that are looking at affordable financing schemes that persuade building owners whether they're landlords or literally building owners, occupant owners, to refurbish their buildings, and there's a wide variety of these things. My own view is all of them need very strong market regulation, which is consumer-centered, and indeed even the people who do refurbishments, you increasingly look at one-stop refurbishment operations, also they need very, very strong market regulation. Otherwise, I think homeowners are going to be spending more money than they should do. And one of the key issues, literally the elephant in the room on this, is fuel poverty. Fuel poverty is where the occupant of building spends more than 10% of their disposable income on energy. And it has two factors. There's the energy cost in there, and there's the income of the home occupant. Energy costs have increased, but also because of recessionary pressures, incomes have decreased. So the number of people in fuel poverty has actually substantially increased and varies widely throughout Europe particularly. And there need to be interventions that basically do the job for those occupants and refurbish the buildings without, in my view, any cost accruing at all to the occupants. And schemes that do that would need, again, to be very carefully regulated, carefully policed, to make sure that there is not inappropriate profit-taking, etc. But it is a critical thing to do. Okay, to bring this to a conclusion, there are, in energy and decarbonisation of buildings, there are multiple different factors and actors. Architectural things, technical aspects, issues to do with climate that I've not really touched on this morning, a whole lot of economic factors, even planning factors, where buildings are located, where they're co-located, their access to solar radiation, for example, the sustainability of the transport network that serves them, all those kind of issues. So that energy buildings has a whole range of factors that influence it. There are multiple benefits that accrue in terms of reducing CO2 emissions, in terms of quality of life for the occupants of buildings. Some of those are for the public good, some of those are private good, and there's a regulatory issue there as well. So things accrue differently to different stakeholders. I mentioned already the influence of what accrues maybe to a tenant as opposed to a landlord who refurbishes the building. But the holistic picture needs to be taken into account, and regulation needs to make sure that all those multiple benefits are instant in terms of each instance of policy decisions that can be carried through to maximum benefit overall. And indeed, it needs a political philosophy that assumes that there are both public and private goods, and that's a politically contentious position. Okay, to summarize. There's no silver bullet. There's no one thing that decarbonises buildings. Certainly needs to be a revised legislative framework, and we saw inclusion of, for example, domestic gas in the ETS would do some of that to get to near zero greenhouse gas emission buildings. There is the need to completely phase out fossil fuels and supply renewable energy, decarbonised fuels into buildings. And again, that is subject, it's obviously to do, but it's subject to pressure for incumbents, the very long lead times on replacing things that are being installed now, and indeed with certain kinds of installations where you might have a gas backup in a heat pump, for example, is that gas backup really still a gas boiler? Those things like that. Reduce the energy use of buildings, obviously, so lots of insulation, ventilation, heat recovery, the highly insulated windows, draft proofing, etc. Looking to reduce the embodied CO2 emissions in building materials, components and systems, so decarbonisation of the steel sector, of the cement industry is critically important, and that will require replacement of feedstock, so more renewable electricity in steel production, probably hydrogen in cement production, and much greater efforts on waste heat recovery in the cement sector. There's huge opportunities there which have not been realised. As I've said, promoting investments, and then using all kinds of grants, incentives, so that we are tripling, doubling the current rate of building renovations. Thank you very, very much for listening. Happy to answer questions.
Thank you, Brian, for finishing very quickly in time. Henrik. We need a microphone. A microphone is there. Okay.
Thank you very much. And thank you very much for an excellent presentation where you really highlighted the many challenges of decarbonizing the buildings. I have been involved a lot in the district heating and district cooling technologies. Also been involved in making Heat Roadmap Europe, the many studies for the past 10 years. And with that background, I was a little bit disappointed on your slides in the beginning, because you were always talking about supplying the buildings with electricity and fuel, and you didn't mention heat and cooling from district heating and district cooling. Then in the middle of your presentation, I was very happy because I saw the word district heating for the first time. Then I was a little bit disappointed in the conclusion because you didn't mention it there. So what I'm trying to say here is there is an emerging, for example, district cooling. There is an increasing number of district cooling in Europe now. And they have a very interesting role to play. When we are insulating the building so much, we also are increasing. Also in Scandinavian countries such as Denmark, Sweden, Finland, we have district cooling systems. They can decrease and make more efficient the electricity for cooling by a factor 10, sometimes even more. So my question is, why have you left out district heating and district cooling, and what is your view on those, for me, important technologies? Thank you.
Thank you. I first of all agree, and in a short presentation, one can't deal with everything comprehensively. And as you saw, particularly in the connection between buildings and other sectors, district heating is critically important. It also has, I think, a critically important role in historic buildings, where the kind of interventions at an individual building level for heat pumps in many systems may be very difficult. So it has a very important role. My view, maybe slightly contrary to yours, would be that there are circumstances where you've got a district that you can heat. And a lot of those have been taken in Europe. Often the district may be coal-fired, but it exists, okay? In other parts of Europe, you don't have something that could be recognized as a district. I live in Ireland. Ireland, aside from 2 large cities, is primarily rural. And it would not be cost-effective to use district heating in that kind of context. So the amount of increase of district heating from where it is now may not be great, and that particularly in some jurisdictions. So I think it's a matter of horses for courses, and if the district heating option in historic buildings, and even sharing heat networks in groups of new buildings, for example, and sharing the energy from a heat pump that's generated to get capacity factors would be good. But I think in terms of interventions, even with new district heating networks, you still want to reduce the actual energy consumption to make the district heating network viable in itself. So there's an optimization between the two that needs to take place. And in my opinion, it's not one or the other. It's an interaction of these things that you're both looking at the actual demand and you look at the supply. But certainly I would totally agree that it's the production of new energy to the building, either electricity or heat, but also reduce the use of energy in the building itself that becomes important. I'd also, by the way, believe that actually energy storage in buildings also needs a lot more attention as well. So there's a variety of things there, but I think it's geographic context and market maturity issues come into play as well.
More questions? Birol?
Thank you. This is Birol Kılkış, and thank you very much for your presentation, and also thank you, Professor Lund, for your comments. So on the side of Dr. Lund, I would suggest microgrids, micro-district energy systems, if we are speaking about rural areas. This will also help to level off the peak loads by prosumer buildings, and therefore there are several advantages. And in the case of district heating, the only caution that I would like to make is the pumping exergy. If you go to a very large district, the pumping exergy demand might exceed the exergy of the heat that you distribute. And this, in this case, will be responsible for nearly avoidable carbon dioxide emissions. So the solution might be, of course, after optimizations, micro and mini district heating, if the pumping exergy is crucial. Thank you very much.
Yeah, I don't disagree. I think, though, as I said at the beginning of the lecture, in terms of looking at energy in buildings, one needs to start with the actual loads of the building. What is the distribution over time of the heating, cooling, lighting, cooking, hot water loads that are there, and then devise solutions that meet those, okay? Rather than starting off with a technical solution and saying, I believe in district heating, or I believe in solar thermal or PV or whatever, and that's the technology. The technology will come out of the application, and there will be applications where a micro district heating system would be appropriate to the loads, to the co-location of the buildings, to the climate, etc. There'll be others where other strategies will be more viable. And I think, I don't disagree, but I think it needs to come out of an analysis of the building rather than any technocratic solution that's imposed upon the building.
Thank you. Ingo?
Thank you very much for your presentation. When you less see the district heating system as a solution, but more the renewable electricity, and you do not only look on a single building, but on the building stock, did you also take into consideration in your research the effects on the grid infrastructure when a large majority will go for electric heat pumps? And there is a need then for heat storages or other storages? And in case yes, in which time frame do we need those storages?
Yeah, my own view is that one of the reasons you need to reduce energy use in buildings to start with is to reduce the load that's met. So you're not meeting with the current electricity infrastructure the current load. You're meeting with a future decarbonised energy infrastructure, a lower load within buildings, but also new loads in the decarbonisation of industry and new loads in electric vehicles, for example. So there are other pressures on the grid, particularly from electric vehicles in timing, that are going to be far greater than so the first step is to reduce the energy use in buildings, okay? Then seeing how the energy use is best met, and it could be, for example, with the electricity to a heat pump. It could be through district heating. As I've said already, there are particular building types, historic buildings being one, by the way, which that's applicable. Or there may even be particular heat sources, waste heat from data centers, geothermal, etc., which make district heating particularly attractive in a particular location. So, but certainly the key thing is to actually reduce the requirement on the grid from buildings in the first place. Okay, there will be other requirements that are going to increase and indeed don't even currently exist, which will also influence that in the future.
Thank you. We have one question there. I'm not seeing the person, so oh, okay, there was one here. I see the lady there. Please introduce yourself.
Thank you very much. Katharina Gab-Schmeling from Germany, from the ITES Research Institute. Thank you very much for your talk, which kind of summarized all the challenges that we came across in Germany for the heating transition in the building sector. I have a totally different question because you now discussed district heating so far. What about, because we discussed this in our institute and in Germany as well, so I'm interested in your opinion. What's your take on carbon prices to use to finance funding for low-income houses to have their owners do the renovation? Thank you.
So what sort of prices? Sorry, I didn't quite catch that. Having what prices?
If you have carbon prices and you use them to finance the renovation for low-income homeowners.
I don't understand. You have to explain. Oh, carbon tax. Oh,
sorry.
yeah, okay. Yeah, taxes. Yeah, okay. That's, to be honest, that's essentially what most states do. The actual, one way or another, they are recycling levies to offer subsidies to low-income houses. So that essentially is what a large number of states do. One needs to be careful in the detailed construction of how that pricing is done. If I give an example of that, if you look, for example, in many jurisdictions, an electricity bill will have two components. It'll have a variable component depending on how much electricity you use, and it'll have a fixed component, which is a legacy of when electricity systems were socialist and everyone contributed to the maintenance of the grid. So there's a fixed component, all right? A lot of people say reduce that fixed component and that would reduce fuel poverty, etc. Unfortunately, the amount of energy people use doesn't correlate with their income, all right? So that if you did that, in fact, the prices would go up to poorer people, etc. So one does need, when we introduce costs, new taxes, new interventions, that they don't, whilst giving money that enables certain measures to be done, they don't also, prior to that, penalize the very people who the measures will actually then affect. So there's a very careful construction of how the revenue stream isn't actually taxing the people who are going to benefit. It's actually taxing other people and resulting in a net transfer. So that just is something you need to be very cautious about. It can be done. It's not. I'm going to say it's not difficult. It is difficult, but it's not impossible. But you do need to be very careful. There are already lots of distortions in energy markets, particularly consumers. In fact, electricity markets is a good example. You talk about electricity market. I believe it's a market on the wholesale side, but in many jurisdictions, it's not really a market at the retail side. The ability of people to behave as consumers to behave as market actors is very limited, and that applies with any intervention on fuel poverty.
Thank you. Peter?
Peter Varbanov from Bern University of Technology. I have this question. I fully agree first with the hierarchy. First should be energy saving, especially considering the shares of how much energy is used and how much energy is wasted in the economy and especially in buildings. So the question within this context is how do you see the role of integration of energy flows, thermal flows especially, inside the buildings, between the buildings, and maybe some storage, short-term, long-term. What do you think?
Yeah, first of all, storage is going to be critical. Storage in the building at a variety of levels, storage within the system, electricity systems, the district heating system, etc., are going to be critical in terms of matching energy inputs to energy requirements. And systems do need to be revised from a system perspective, because your prosumer, if you're producing photovoltaic electricity, or indeed you're producing heat from a heat pump that you haven't got use of yourself, you need to have both the physical systems and the market models that enable others to then take those energy from you in real time, okay? And most of us are not going to be trading electricity from home sitting here, so it needs apps, it needs providers, it needs facilitators that enable those things to happen in a fair way, in a transparent way, and in a regulated way. But yeah, I think system integration is going to be key to the future, both in terms of heat systems and electricity systems, and particularly when you look at examples where you might have distributed interseasonal heat stores, maybe thermochemical, etc., which would serve a number of buildings. That will become very, very important.
Thank you.
Thank you. Well, I would like to ask from my side, there is a lot of discussion on social networks. Whenever I write we should go to electrification of heating, the response is we first have to retrofit the buildings. So it's a kind of delay tactic. Let's do it in 20 years' time, because it takes a long time to retrofit all the buildings. I am living in an 1850 building, which is probably G-class, and was not able to retrofit it because other neighbors don't agree with that. And I wanted to move away from gas. And they didn't want to bring me district heating, so I put a heat pump. And it works very well, no problem. No insulation whatsoever, and it's perfectly warm inside. So why, what do you think about that issue? I agree that we should retrofit, but it's not a precondition to decarbonize the heating, in my opinion.
No, and you are correct. It goes back to the point I made earlier on. You start with an analysis of the building. What is possible, what is desirable, and for example, a historic building, older buildings, there are limits to how you can change the fabric, you can change the glazing, etc. So in those circumstances, a focus on decarbonising the energy going into the building and the systems that harness that energy in the building, heat pump in your instance, would be important. However, there are many, many other buildings which exist of higher, whole groups of buildings that are very, very similar, where a group refurbishment could be done within a month, 2 months, often with interventions that are exterior to the building, so you don't even need to decant the people out of the building to do it, and would substantially reduce the energy use of those buildings, which could then be part of a district heat network or part of an electricity network. So it starts off with an analysis of the building in all its respects. What is its function? What are the constraints? What are the opportunities? And then flows from there. Again, not following a dogmatic position that you have to refurbish everything, okay? Or a dogmatic position, which is an equally dogmatic position, that the solution is simply to decarbonise the grid. It's a case-by-case kind of analysis that needs to be carefully done.
We are now already moving into lunchtime, but we have 3 short questions, please.
Yeah, well, it's not a question, but a remark. I'm Ivo Potov from TU Delft. I fully agree with your own personal experience with N equals 1, but luckily we did a large-scale measurement campaign in the Netherlands in 200 individual dwellings that confirmed that 60% of those dwellings is already, so yeah, LT ready, you can say, so ready for low temperature heating without any modification to the heating installation or the building envelope. And that gives a lot more flexibility to decarbonize the existing building stock. And the journal paper that we drafted on this topic has just been accepted for publication in Energy last Friday, so it's currently in publication. So I can confirm your personal experience with a large-scale experiment.
Yeah,
Thank you.
Yeah, but actually just on that, and congratulations on the paper, but the point I was making earlier on is that because there has not been wide-scale measurement of the energy use in existing buildings, there are lots of assumptions that older buildings are energy inefficient, that for lots of reasons, and as I said earlier on, to do with how the calculation is done and to do with what homeowners actually done to their buildings, is not always true. And so you need to start off with a real evaluation of the particular building.
Reinhard?
Also a remark. Neven, do not take it personally, but I think you do not heat with electricity from renewables. Because in wintertime, when we need a heating system, we generate the marginal kilowatt hour, I don't know, from natural gas or even from coal. And maybe in 10 or 20 years, we managed to have the 100% renewable system, and then it could be the case that you heat renewable, but I think it's not the case today.
Okay, that's a question to me, I would say. Well, I disagree with the marginal approach, because if we look at the marginal approach, we're going to wait for a very long time until we completely remove gas from the power sector. The average carbon intensity of electricity is extremely low now in Europe. And if you take into account COP, even heating sometimes on gas is not that bad with COP3. And if you are doing it with district heating and have heat pumps which have COP6, you're excellent, even with gas. So I think we should do these things parallelly. I don't know if you want to...
No, I would...
Okay, we have one more question there, and then I'm closing it.
Last comment here, Robert Advice from VTT Finland. I support your comment about the heat pumps, and I would like to stress that You can also install hybrid heat pumps that work most of the time in heat pump mode when you have cheap electricity, renewable energy, and in the peak times in the winter, you can use a little bit of gas to boost it, and it works well. The main issue, as I see, is commercial and tariff. If you have very high electric power rates and very cheap gas, as we had in many Central European countries, not Finland, but Central European countries, and no heat pumps will be installed because of economical reasons, not technical reasons. So this, in my opinion, is a very economical and economical control question.
That's why we should stop subsidizing gas, and then you solve the problem. You want to comment?
Yeah, no, I mean, I think fossil fuels need to include their externalities in the price. That's a more polite way of saying what Nevin's just said. But also, market structures do need to reflect the real costs of energy production and real profit margins. So, for example, where renewable energy was tied to the price of gas because it was the lowest price fuel, renewable energy costs went up when gas prices went up. That's not unexpected, and you need, when you're developing market models, to actually do the risk analysis, do the what-if scenarios, so that your models are robust and don't allow profiteering, even by renewable energy operators. You know, there's a simple view of saints and sinners in these things, of renewable energy being saints and fossil fuels being sinners. That's not true. And market signals and market constructions can give very strong perturbations of markets that work against consumers and work against energy efficiency.
Thank you. Thank you, Brian. With this, we close this session, and now it's the most important session of today, the lunch. Let's see you back in parallel rooms in 1 hour.